air would be blowing from the water body towards the sea. So wind blowing from the sea towards the land, it is called as sea breeze. So during the daytime, what happens? The land in the coastal areas, would be getting heated due to sunlight. Sea also gets heated, but however, sea takes more time to get heated than the land. So the air above the land, it gets heated faster than the air above the sea. So thereby, hot air from the land rises above as it is lighter, and cooler air from the water body, it will rush towards the land. Since the cooler air above the sea is heavier, so it is going to rush towards the land and takes the place over there. So this results in sea breeze. So during day you have sea breeze where wind would be blowing from the sea towards the land. During the day, opposite happens. During the day, what happens? Wind would be blowing from the land towards the sea. So during the night time, what is happening now? Particularly the land in the coastal areas, it cools down faster than the sea, because it's the property of land that it heats up faster, but also it cools down faster. So the air above the land during the night, it is colder, and the air above the water body during the night, it is warmer, because water warms up slowly and it cools down also slowly. So during the night, water will still be warmer. So if you happen to visit a beach, or and if you were to go into the water, you will feel that as compared to the land, the water will be warmer during the night. Getting it now? So what is going to happen over here? The air above the sea, it will be warmer, it will rise up. It is going to rise up now. Getting it? It is going to rise up. So, and empty space will be created over here. So the air above the sea, air above the land being heavier, it will start to move towards the sea. Getting it now? So this results in land breeze. Okay. So hope you guys have understood this. Now we can understand about the sea breeze and land breeze on a broader scale. Sea breeze and land breeze on a broader scale. Like in the summer season, what basically happens? In the summer season, like in the months of like May, June, or July, you get to see that India is having monsoon, southwest monsoon. This is north, this is south, this is east, and this is west, right? So during the months of like May or June and July, during these months, India would be receiving monsoon. India would be receiving rainfall due to the southwest winds coming from the Arabian Sea. So what basically happens? Apply the similar concept here, just like you have understood in the case of sea breeze, where the winds were blowing from the water body towards the land. So here also, you know that during the summer season, what is going to happen over here? The air above the land will be heated up, it will rise up, isn't it? The air above the land is going to rise up. So an empty space will be created over here or not? Warm air is lighter and it rises up. So it will rise up. So an empty space is being created over here. So thereby, the air above the water body, which is still cool and which is still heavier, so it will rush towards the land in order to occupy the empty spaces created over here. You guys getting it now what I'm trying to say?
Yes, sir.
So that is also the same concept of sea breeze, but on a bigger level, but on a bigger scale. So sea breeze has got a bigger role to play here. In the climate changes also, sea breeze has got a role to play, right? So southwest monsoon, like monsoon winds are coming from which direction? From the southwest direction. Look over here, from the southwest direction. So India receives southwest monsoon during the month of particularly June to September. And how does it happen? It is happening because of sea breeze. But as you asked one question to me, Aman, that why Rajasthan does not receive any rainfall right now. So the thing is that there are Aravalli hills right over here, and Aravalli hills are running parallel to the southwest monsoons that are coming from the Arabian Sea. Yesterday, I also told you via little bit of demonstration, like these are the Aravalli hills. Hope you guys can see. By the way, am I visible to everyone or not?
Yes, sir, you are visible.
Uh, so see that this is a let us say this is Aravalli range. Fatima, you getting it? What we are discussing? This is a Aravalli range, and these are the moisture carrying southwest monsoon winds coming from the Arabian Sea. So these are running parallel. These are kind of running parallel to it. As you can see over here, look at this direction over here. The winds are being deviated due to the Aravalli hills over here. So it kind of obstructs the southwest monsoon winds. So Aravalli hills are running parallel to the southwest monsoon winds. So thereby rainfall does not reaches to parts of Rajasthan. So it receives very less rainfall. Okay, no? So hope you guys are able to understand this thing. Okay. Furthermore, what are some practical applications of convection in our daily life? So we have practical applications like you get to see that since we know that warm air is lighter in density, it is not heavier, it is lighter. So thereby it tends to rise up. So in your room, where should you be placing the ventilators? Close to the floor or close to the ceiling? By the way, everyone turn on their cameras. Aman, Fatima. Fatima, you getting these concepts now? What we're discussing? Yes, Suleiman. I
Yes.
have asked a question to you guys. In a
Sir, at the
room,
top.
in the top, obviously, so that the warm air can escape. Another application of convection is that you know that the room heater should be placed on the floor of a room and not on the top of the room or not near to the ventilator. Because if you were to place the room heater, suppose you have placed the room heater over here, let us say over here. So then what is going to happen? All the heat will escape via the ventilator. Let us say there's a ventilator over here. This is a room heater. So all the heat will escape via this ventilator now because warm air is rising up. So it's logical to place it near to the on the floor of the room so that heat will spread into all directions of the room and the room will be heated. Is that clear to everyone?
Yes, sir.
Furthermore, exhaust fan. Exhaust fans in the kitchen are also placed on the top right now because smoke coming from the cooking of the food would be rising up now since it is lighter in density. There are different kind of exhaust fan like this one or this one also. So it is logical to place them in the upper part of the room. So these are some practical applications of convection in our daily life. Exhaust fan in kitchens, room heaters being placed on floor of a room or ventilators at the top of the window or the top of the door. So hope you guys have understood that. Is that clear to everyone?
Yes, sir.
Fatima, you got it? Aman, you got it?
Yes, sir.
Not getting it.
Sir, sir, can you please explain again?
Okay, sure. See, what basically happens here, no? See, this is your room, for example.
Hmm.
Okay. This is, let us say, the inside of a room.
Hmm.
So thereby you tell me, we know about the property of warm air. Like whenever air is warmed, it tends to rise up.
Hmm.
Warm air,
Tends to
warm
rise up
air,
because there is just hide less dense.
it is less heavier. Its density is less. It is
Hmm.
light. So
Hmm.
warm air, it is light and hence it rises up. Have you guys seen the helium filled balloons?
Yes, sir. Sir, it when we fill the helium in the balloon, sir,
Mhm.
it just starts to go up, and sir, you cannot stop it. If
Mm.
you, sir, like if you put helium in a balloon and just leave it in a ground, sir, it will just
Mm.
get going and going.
The reason being is that helium is a very light gas.
Yes, sir.
Okay, no. So similarly, whenever air will be warmed up, it will become light and it will go higher up. So thereby, um, when in the room, where should the ventilator be placed? Like if your room is heated, so if the heat from the room has to be escaped, so it's obviously logical to place the ventilator on the top of the window, on the top
Yes,
corner of the room, from where heat can escape,
sir. In the
right?
room where I study, sir, there is no ventilator, but sir, there is
Mm.
one such place, sir, where is one window, and sir, like
Mm.
what can I explain, sir? Sir, like a
And
jail
this
type
one.
something. So, sir, yes, sir, yes, sir. It's only
Mhm.
like that, but sir, like a jail type net something attached there. And sir, it's like the
Okay.
shaft of the apartment.
See over here. See. From the window now, like you can understand it in this manner. Like a window is also
Sir, I
important
have a doubt.
and a ventilator is also important for a room. Just let me just complete this one. See,
Yes, please.
from the window, cold air will be coming in into the room, right? From window
Hmm.
is there for the purpose of allowing cold air to come inside the room. Okay. And
Hmm.
this cold air that is coming in your room, suppose it gets warmed up, like you are
Hmm.
cooking in the kitchen, or you're doing some activities, so thereby air will be warmed up. So that air can't go through the same window, it can't go out from the room via the same window, because the windows are usually not that much higher, not at that much high level in the room. So for that purpose you have got ventilator, it will be in the top corner of the room. So you'd be having an exhaust like this, or you'd be having a
Yes,
ventilator in
sir.
the room
Where in
somewhere it
some
can
homes,
escape.
sir, there is like a big thing called an exhaust, and it's like
Exhaust.
really big, and it has some options to turn the fans on.
Like that. Getting it
Sir,
now.
what is the work of the fan in the
Hmm.
exhaust?
In the exhaust, so it basically will suck up the air, it will basically suck up the smoke.
Oh, sir, and
So
the
that is it.
warm air.
Basically the warm air, and if there's some
Oh,
smoke
sir,
in the
that's
air.
why it's just placed just above where you cook the food.
Exactly, like you can see over here,
Sir,
just
I have a
placed
doubt. Yes,
right
sir.
where you have you're cooking the food, so
Hmm.
smoke would be coming out of it, so it will basically suck up.
But in my
And
home, it is only the same.
same, very good. Okay now, so that is the thing. So hope you guys have understood about convection. Okay, next we're going to learn about conduction, and furthermore we'll be learning how conduction is different from convection. See, in the case of convection, by the way, Rita, you are so silent. You're getting these concepts or not? Hello?
Yes, sir.
Okay. See,
Sir,
in the case of, yes, sir, Aman.
yes, sir, I had a doubt.
Yes.
Sir, I'm saying that, sir, in my room, sir, when the
Mhm.
ventilators are still closed, like
Mhm.
the window is closed, sir, still in winters, when we turn on the heaters, sir, the
Mhm.
room still doesn't heat at all.
Okay, even when the ventilators are closed.
Yes, sir. And the heater still new, newly bought.
Okay, it has to depend upon what is the size of your room and for how many minutes
Sir,
or
it's
hours you
like
have
the
turned on the.
medium size, not too big.
Mhm.
Sir, like the laptop. Sir, obviously you have seen a laptop. So like thrice its
Mhm.
size or twice.
Oh, okay. Okay, there might be some reason for it. Getting it. There might be some reason for it. It has to
And
depend
sir,
upon several things.
instead of the room being warm, sir, it gets cold. Sir, more.
It gets cold. Opposite is happening.
Yes, sir. Sir, the
Okay.
more we turn on the heater, sir, the more it gets cold. And
So
sir, when we
basically,
open the ventilators, sir, it gets really warm out there.
okay. So your question is why sometimes room heaters fail to work.
Yes, sir. Sir,
Hmm.
even though the heater is still new, newly bought, just like
See,
recently
you need
we
to
bought it before the
hmm,
winters.
you actually need to change the thermostat of the room heater. You see
Sir,
that
we did.
candle like.
Sir, we tried it also.
Mhm. Okay, then you should be replacing the room heater then, I believe. Okay, now there might be some other connection issue in that. Otherwise, it should be working. Okay.
Sir, but the first heater we had instead of that heater, it also didn't work.
Then
We
I believe
also
there might be
changed
some
that
other
one
issue.
thermometer also.
Then there might be some other issue. Okay, now see.
Okay,
See,
sir.
while we were talking about convection, what an important concept we learn in the case of convection, that heat is being transferred from one part of the medium to another part via the movement of the particles. Like when you boil a given solution, like you have this solution over here which is being boiled. So particles are showing movement. Like the particles that are close to the bottom, they are getting heated up and they become lighter, because we know warmer particles are lighter in mass, lighter in density. So it will rise up as it goes to the surface. It will again become heavier. It will cool down and it will become heavier. And heavier thing tends to fall down. So it will again fall down, again get heated up, and it leads to a cycle called as convection current. Convection current is seen in the case of air, and convection current is seen in the case of water body also. Right now. So, but in the case of conduction, what you would be learning in the case of conduction, particles will not be changing their places. It will remain at the same place. So, how heat is transferred? Heat is transferred because of the collision of particles of that substance. Like this part of this object that is exposed to the heat now. So, all the atoms of this part, all the atoms, all the particles of this part will start to collide with each other. They will start to vibrate. Getting it, guys? So like see, you have one atom over here, this over here. So it will collide with the another atom. This will again collide with another atom. This will collide with another atom, like this. So they are colliding with each other, and in this manner energy will be transferred to the consecutive atoms, to the consecutive particles, due to collision. So it's not like, let us name them like this. Let us say that you have A, B, C, A, B, C, and D. It isn't like the particle A moved over here. That doesn't happen. It stays at its respective place. It just starts to vibrate. You have seen a jumping ball, how it will be just like kind of vibrating, or just you have a vibrating particle, or you have a tuning fork. You understand about a tuning fork? You hit one end of it, it will be vibrating. So it's not like it changes its place. It stays at the same place, but it simply starts to vibrate. You guys know what is a tuning fork or not? No? Okay, get back to this concept, what we're discussing. So here the atoms, the particles are actually being referred to the atoms here. Okay, no? All objects are made up of atoms. So atoms would be vibrating, and via vibration they would pass on energy to a next part, to another atoms, and in this manner heat energy will be transferred from one position, from one end to another. So due to this, the heat will be slowly passed on to the another end of this object over here. So conduction is the transfer of heat from a hotter part of to the colder part of an object due to collision of its particle. Collision of its particle. Particle here refers to atom. Without the actual movement of the particles from their position. It's not like the atom A went over here. That doesn't happen. Which we saw in the case of convection, where particles were moving. Like you had this beaker, you boil the water in it, so the particles would move over here and it will then move over here like this. A convection current was seen there, but that doesn't happen in the case of conduction. The particles will not move from their respective positions. Okay, now furthermore, this mode of transfer of heat will be seen in the case of solid substances that are in direct contact with each other. So hope that much is clear to everyone. You guys getting it or not?
Yes, sir.
Aman, Suleiman, you guys understood this? How does conduction of
Yes.
heat occur? So it occurs due to collision of particles. Collision of particles. It is in the same manner like you would have seen this. What do we call this? I'm forgetting about this. Like you would have seen like different cards would be stacked like this. Example, different cards would be stacked like this, and you push one of them, all of them will start to fall. What do we call this? Anyone knows? Like you have a stacked cards in a line and you push one of them, every card starts to fall. What do we call this? Basically what I'm trying to explain over here, like the energy is transferred from one card to another, from this to another, from this to another. From the first card, the energy is transferred to the last card as it strikes another, as the first card collides with another, it collides with this one, it collides with this one, and like this. Yes, so kind of similar thing is happening over here. Okay, now, so hope you guys are getting it. Okay, then what are the practical applications of conduction in our daily life? So for example, pans that are used for cooking, they are usually made up of metals like steel, copper, or aluminum, because they are good conductors. These solid objects are good conductors of heat right now. While the handle of the cooking utensils would be made up of a bad conductor. Would be made up of a bad conductor because you don't want your hand to get burnt. So it would be made up of plastic. So you'd have seen the handle of the kitchen utensils like this over here. It would be made of a plastic, and particularly a type of plastic called as bakelite is used in order to make the handles of the kitchen utensils. Getting it now? Because it's a bad conductor of heat. So that is the application. Apart from that, you see that clothes that are made up, clothes made up of fur traps air inside them, and this trapped air then acts as an insulator. So it prevents heat from escaping, keeping your body warm. But the second one is actually will be an application of convection actually. Okay, so this one will not be counted in it. So the practical application of conduction is used for making cooking um, used for making pans of the cooking utensils. Right now, pans used for cooking. So it would be made up of metals which are good conductors of heat, while the handles would be made up of a poor conductor. So hope you guys have understood this. Answer this question: which of the following is an insulator, which is a bad conductor of heat?
Sir, in the chat box.
Yeah, in the chat box.
Sir, can I tell?
Okay, Suleiman, you have answered. Fatima, you also answer. Then Aman, you can answer in your class.
Copper or
No, Aman.
graph,
It's
graphite.
see you have to answer which is a good conductor. It's air now. Which is a bad conductor. I mean to say, because the following is an insulator or a bad conductor. So air is a insulator now. Getting it now?
So, sir, we only have to tell it now. Which of the following is an insulator?
Yes. Which of the following is an insulator? So air is
Sir,
an
I only
insulator.
told it, sir. I said in the chat box B.
Good. So then this question like this: is a graphite an insulator? Hmm?
Yes, sir.
Graphite is
Graphite is also.
Mhm.
Sir, pencils are also made with graphite now.
Yeah, the pencil lead is made up of graphite
Sir,
only.
wouldn't it be an insulator?
No, it's not an insulator. It's a conductor of both heat and electricity. Okay.
Oh.
So don't get confused about it many times. Students is confused. So it's a conductor actually. Okay, the process by which heat flows from the hotter into the colder end of an object. What do you call this as? Is it conduction, convection, radiation, or vaporization? Yes.
Radiation.
No, it's not radiation. We haven't even learned about radiation yet. We read the question 1 or 2 times and no. Fatima, speak a little bit louder. Aman, you have answered it no? Suleiman, you also answered it. The process by which heat flows from the hotter into the colder end of an object. Like you have a object over here. So this is the hotter end and this is the colder end. And heat is flowing from the hotter into the colder end. Via which method it happens? See, it can't be a convection. It can't be convection. Like for example, we have learned this like in the case of conduction, what did we learn? Heat travels from the hotter end towards the colder end now. Why conduction? So that is conduction. Okay. No, see, stainless steel pans are usually provided with copper bottom. What could be the reason for this? If you were to look at the stainless steel pans, they are provided with a copper bottom. Why do we do that? See, while you're cooking the food, you would choose to use such a material which is a good conductor of heat, isn't it? You will prefer using a material which is a good conductor of heat. So the base of the cooking utensils are being made up of copper. The reason is that obviously it's a better conductor of heat than the stainless steel. That's why we would be using it now. Yes, Suleiman, Aman, and Fatima. It's not because it makes it more durable or other thing. No, it's not like it appears colorful. No, or it is also not because it is easier to clean than the stainless steel. The main reason is it's a better conductor of heat than the stainless steel. Hope you guys have understood that. Clear or not? Please tell me.
Yes.
Good. This question we would be learning in detail while we'd be learning about radiation. But still, if someone knows, you can answer it. Although we are going to learn about it after radiation. In radiation, we are going to learn about it in detail. Yes, Fatima, Aman, Suleiman.
Sir, summer.
Summer season. Very good. Okay. Answer this one, everyone.
Sir, gases.
No.
Sir, we have to answer
Sir,
this
is
in the
it
chat
all of
box.
this?
In the class only. Yes,
Sir,
Fatima.
solids.
Sir,
Sir, solids.
Yeah, it's solid actually. Okay, Suleiman, you were also answering the same.
Sir, I only answered once and the answer was solids.
Yeah, good. See, Fatima, the thing is now, while we were learning about convection, there we learned that convection would be taking place in the case of water. Okay, now, when you are heating up any liquid, whether it be water or any other kind of liquid. So there heat would be transferring via convection. Heat would be transferring via convection in the gaseous medium also. So transfer of heat in a gaseous medium and in a fluid medium, in a liquid medium, will take place via convection, where the particles would be moving from one place to another. The particles of the liquid or the gases will move from one place to another. But in the case of conduction, we learned that conduction only takes place in the case of solid. And since solid objects are the particles of solid objects are compactly packed, so therefore particles can't move from one place to another. They would be only vibrating at their respective places. They would be colliding with each other and hence passing on energy to next particles. So conduction transfer of heat The question was the flow of heat by conduction is observed in the case of solids only. Okay. So hope that is clear to everyone. Now let us understand what is radiation and how heat is transferred via radiation. See, first of all, you guys tell me the sunlight, the heat of the sun that is coming on Earth, the sunlight that reaches the Earth, it contains heat energy in it. Interestingly, between the Earth and between the sun, the majority of the medium is basically vacuum, isn't it? Do tell me, how much time does sunlight take to reach on Earth? I'm asking a question apart from the concept, just a general question. What is the time taken by the sunlight to reach Earth? Yeah, Suleiman, Aman, Fatima. Okay, I'm giving you options. Does it take 8 minutes 20 seconds? Does it
Yes, sir.
take
8 minutes 20 seconds.
10 minutes? 8 minutes 20 seconds. Very good. Okay, but you know, like the sun is about 93 million miles away from Earth. How much? 93 million miles away from the Earth. Getting it, guys? Okay, anyways, that's a different thing. But what I meant to say is that the vast area, the majority of this distance, the majority of this 93 million miles of distance that sunlight travels, sunlight covers from sun to earth is basically vacuum, is basically space, basically vacuum. But still you get to see that heat is reaching on earth. Although the medium is neither solid, liquid or gas, but still there is no medium, but still heat is reaching on earth. So radiation is that mode of transfer of heat where a medium is not necessary. Getting it, guys, or not? So this is, say this is sun and this is earth. And this is the atmosphere of the earth. And in between that, this is 93 million miles of distance. That much is the distance between the sun and earth. And the thickness of the atmosphere, like do tell me about the thickness of atmosphere. Anyone learned about this in the geography? What is the thickness of atmosphere? Hmm? You have learned about, like, our atmosphere, you know, what is the thickness? Only 60
Sir,
miles.
it is 60 miles. Yes.
60 miles, very good. Now compare it with 93 million miles and 60 miles. Hmm? It's in million, it's in just 60 miles. So the vast majority over here, just you subtract 60 miles from this 93 million miles, it wouldn't even be such a big difference. So this is basically vacuum, and the sunlight interacts with the medium only when it comes in the atmosphere of the earth. But still you get to see that without any medium, heat is being transferred. So that mode of transfer of heat is radiation. Also, heat here will be transferred in the form of rays. Getting it now? So for example, the heat from the sunlight is traveling in the form of a wave called as electromagnetic waves. Getting it? Okay, no? Okay. Also, you guys tell me, like whenever air is warmed, so warm air will tend to rise up or down. It will go in the upward direction or will it go in the downward direction? Warm air will go in the upward direction or in the downward direction. Yeah, Fatima, where will it go?
What's up?
Warm air
Sir,
rises up or goes down?
sir, it will float up, right?
So
It will rise up or down. Mhm.
it will rise up.
Okay, that's what you were saying, Suleiman.
Yes, sir. I said it will float up.
Good. So warm air tends to rise up. But you tell me, like you would have seen this incandescent bulb. Although it is no longer in use, have you guys ever seen this incandescent bulb? It was called as yellow bulb or called as incandescent bulb. Earlier it was in use, but since it consumes lots of electricity, thereby it is no longer used. We have using light emitting diode bulbs. LED bulbs are nowadays being used. So what I'm saying that um, if you were to place your hand just below this bulb, like say this is the bulb, and if you were to place your hand just below it, logically, if you were to think of convection, we know that via convection, warm air rises up here, rises in the upward direction only. Huh? So logically, you would say that the warm air is going to rise up now. We know that this incandescent bulb, when this bulb is switched on now, it gives heat and light both. It gives heat and light both is given out by this bulb. Okay. So you tell me if what is happening when I place my hand just below this bulb, even then my hand is warmed up. Why is it happening? Logically, we have learned in the case of convection that warm air rises up. But why is it that when I place my hand just below this, just below this incandescent bulb, even then my hand is being warmed up? Can you guys explain why it is happening? So you have placed your hand just below it. The reason being is that heat rays are being released by this hot object in all directions. Heat rays are released in all directions. So heat is being released in this direction, in this direction, in this one, in this one. Also, have a look at this one. Like the heat rays from this fireplace is traveling in this direction. Logically, you would say, sir, it should be rising up. Yeah, that is true. It is rising up as well. The warm air, the air that is above this fire, it gets heated up and it rises up also. But then you tell me how you are sitting at a distance from this fire. Still, you are receiving the heat from this. How does that happen? Because as I said that hot objects, the heat would be coming out of the hot objects in all directions. It would be traveling in the form of rays in all directions. So heat would be not just rising up in the upward direction, but it would be traveling in the form of rays in all directions. Getting it or not, what I'm trying to say? Are you guys getting it?
Yes, sir.
So that is the thing about radiation. That is the thing about radiation. And it's the transfer of heat in the form of rays for which a medium is not required. And these waves can even move, travel through the vacuum as we have seen in the case of sunlight. It's a process of transfer of heat in the form of waves, right? Like the sun's heat reaches the Earth's surface through radiation, and every hot object would be radiating some heat into the environment, releasing some heat into the environment. Getting it now? So many times an object just gets heated just by being an object would become heated just by being near to a hot object. Have you guys understood this concept? Many times the student don't get this concept of radiation. Aman, you understood it? Suleiman, Fatima?
Yes, sir. Yes.
Okay, is medium required for radiation? Is medium required for radiation or not? Tell me. Hello? Is radiation required for medium? Is
No,
a
sir.
medium required for radiation? No.
No, sir.
Good. Okay. So radiation, that is what radiation is. Heat will travel in the form of waves. It will come out in rays in all direction. Some of the common examples of radiations are like, there apart from heat is also like you have some other forms of radiation also. You would have most commonly heard of UV radiations. Huh? You would have heard of X-ray. Getting it? You would have heard of ultraviolet radiations. So those are also some of other types of radiations. And how does heat reaches us directly from a fireplace? Moments ago we learned about this. That heat from a fireplace is radiated in all the directions. This is the fireplace. So heat from this fireplace, suppose you are sitting over here. You're sitting over here. So how does heat reaches you? Because the heat from this fireplace is radiated in all the directions. That's why heat reaches you also. It is reaching you as well. Is that clear to you, everyone, or not?
Yes.
Okay. While you are burning this wood now, two things are happening. Convection and radiation both is happening. Can't we say that? The air right above this, air molecules right above this fire, that would be heated and that would be rising up in the upward direction, isn't it? So that is happening due to convection now. And the heat that is traveling towards you, that is happening due to radiation. Aman, you understood it? Suleiman, Fatima?
Yes.
Okay. Furthermore, radiations would be emitted by all the bodies. Like, for example, I have this phone in front of me. So this would also be emitting some heat. This would also be emitting some heat. Uh, every object that you see around yourself, it would be emitting some amount of heat. Your body is emitting some amount of heat. Getting it or not? Uh, so every object would be emitting the heat. But warmer the object, more will be the amount of radiation it will be emitting out. Radiation basically here refers to the heat that it is emitting out. It would be radiations would be emitted by all the bodies. But what factor it will depend? How much amount of radiation will be emitted by a given body? It will depend upon its color and texture of the surface. It will depend upon the temperature of that given object and the surface area. Okay, now. So there are several factors on which radiation emitted by a body will depend. Okay, it will depend upon the temperature of that object, the surface area. Talking about like the temperature. So warmer objects emit more radiation. Warmer objects emit more radiation as compared to the cooler objects. Furthermore, talking about color and texture. Talking about color, so we know that darker objects with dark color would absorb more amount of heat. They would absorb and I mean to say they would be absorbing and radiating more heat than the lighter surfaces. Getting at what I'm trying to say? Darker surfaces would be absorbing and radiating more heat than the light surfaces. So dark colored objects absorb more heat. So that is why in the winters it is preferred that you should be wearing the warm clothes or dark colored clothes, right? So say in a given area, for example, say in your house. So you have, for example, you have a fireplace at your house. This is, let's say, fireplace, or let's say somewhere there's a room heater too, or there is a bulb also. Let us say this is a bulb. So all of them would be radiating heat, isn't it, Fatima? Isn't it true that all of them would be radiating heat in different directions? Okay. And just moments ago, I have told you that dark color clothes, they are good absorbers of radiation. So say that some boy is sitting in this room wearing a dark colored clothes. So dark colored clothes would be absorbing all these radiations. Let us say he is wearing a black t-shirt, for example. Huh? See that he is wearing a black t-shirt, for example, dark colored clothes. So it would be absorbing all those radiations and hence keep your body warm. Understood this concept now, guys? Everyone? Good. Aman, you getting it? Talking about texture. So talking about texture, so thereby dull and rough surfaces would be radiating more heat than the shiny and smooth surfaces. What the concept is? Dull and rough surfaces radiate more heat as compared to shiny and smooth objects. Is that clear to everyone? So these are the different factors which will impact the amount of radiation emitted by a body. Any confusion in this? Please tell me. Suleiman, you understood it? Yes?
Yes, sir.
Good. Then you would have observed that if you were to have a cup of hot tea or hot coffee and you were to leave it for some time, it will become cold. So it is becoming cold. Is it due to conduction? Is it due to convection? Or is it mainly due to radiation? Keep in mind, we have previously learned that all the hot objects would be radiating heat. It would be radiating heat. All the objects should be radiating heat. Particularly the hotter objects should be radiating more amount of heat. Aman, you there in the class or not?
Not there. I mean, sir. Sir.
Yes. You guys are not getting it. Why does a cup of hot tea become cold after some time? The obvious reason is that it is a warm object. Moments ago, I have told you that warm objects should be radiating heat in the form of rays. It would release heat in all directions. So this is a warm object. It would also be radiating heat in different directions. Yes, Suleiman, Fatima, and Aman.
Yes.
So it releases the heat in all directions. So thereby, it is due to radiation that it becomes cold after some time. So hope you guys have understood this. Now here are some of the examples of radiation in our everyday life. Hmm. Like you all would have used the microwave oven. Nowadays we have certain other alternatives of microwave oven also, because food cooked by radiation is not considered healthy. Anyways, but the transmission of electromagnetic waves through the microwave oven. In the oven, the food is cooked due to radiation. That is one such a practical example of a radiation in our everyday life. Or you have the radiators like this. Radiators fit in the car engines or in the houses also. So if you were to stand in front of the radiator of the car, it would be releasing lots of heat. If you were to touch it, it will be warm. Hmm. So this radiator is also basically working on the concept of radiation. So a radiator via radiation is releasing the heat. Okay, getting it now? Or like the light that is being emitted by this incandescent lamp, that is also due to radiation. So that is another one such example of radiation in our everyday life. Okay, then there are some other forms of radiation also, although they are particularly not important, but there are some emission of gamma rays, etc. like that. Later on, we'll be learning in the next class. We'll be learning about some more interesting thing. That's it for today. We'll be learning about working of a thermos flask as well in the next classes.
Yeah,
So
yes,
that's
sir.
it for
Bye.
yes. Allah Hafiz. Bye.